Hi, welcome to another edition of Numero Studio. In this video, we will talk about the measures of variability. Most often, the measures of central tendency do not give us the entire picture of how a distribution looks like. Take data sets A and B for example, each having 5 observations or data points. When plotted on the same scale, the graph shows that the points in set B tend to cluster together and are therefore more consistent than the points on set A, which tend to be farther away from one another. In fact, if we compute for their respective means, both will have 60, which is located where the broken line is. Clearly, the points in set A are farther away from the mean than the points in set B. Also, we are showing that the mean here gives us not enough information on how the two sets are different from one another. Therefore, we can use the measures of variability to get a better picture of a distribution in conjunction with the measures of central tendency. And these are the range, the mean absolute deviation, variance, standard deviation, and the coefficient of variation. The other names for these characteristics are measures of dispersion or measures of spread. First, the range. The range is really just the difference of the highest and the lowest value in the distribution. So in this case, we have 24. However, because we only took into account the two extreme values in the dataset, the range is the crudest and simplest measure of variability. It does not give us an idea of what is going on in the values in between. To illustrate, we have two data sets shown where the range are equal at 80, but the values in between are totally different. The data points at the top are more scattered or more varied than the ones at the bottom, so we can say that there is a greater variability at the top. One clever way to get a better variability is to find how each data point is deviating away from the mean of the entire set and get the average of those deviations. This is called the mean absolute deviation, and it is found using the formula. We put all the observations in one column, find its mean, which in this case is 107. So we have 120 minus 107 is 13. 105 minus 107 is negative 2. And we can do the same to the rest of the data points. These numbers are the deviations of each of the data points from the mean. A positive value means it is to the right, and a negative value means it is to the left of the mean. Because we are only concerned with how far they are from the mean, we can ignore the signs by taking their absolute values. If we get their sum, this is the summation of the absolute values of x minus mean. N is still the number of observations, which in this case is 5. We can now plug in these values into the formula and get 6.4. So here we are saying that the average deviation of these observations is 6.4. In practical applications, however, the next two measures of variability have been found to be more useful than the mean absolute deviation. These are the variance and standard deviation. Now the variance of the sample whose formula is shown. Taking the deviations we have computed earlier, we square the deviations and find 169, 4, 121, and 9 for the remaining values. We get their sum, and this becomes the summation of the squared deviations. With n still equal to 5, the variance is 78. Notice that the unit for variance here is ounce squared, since it is coming from the squared deviations. Now, the sample standard deviation is really just the square root of the sample variance. So here, it is approximately equal to 8.83 ounces. Here are some remarks of our computations. Shown are the formulas in computing the variance and standard deviation of a sample. And if you want to get those measures in a population, we use these formulas. Notice that the difference is in the divisors of n-1 in the sample and n in the population. There is an explanation as to why we use n-1 in the formulas for the sample, but that is not within the scope of this discussion. We will reserve that to a future video. So therefore, if the data on the left represents the entirety of the population, the variance is 62.4 ounces squared, and the standard deviation is about 7.90 ounces. The last measure of variability is the coefficient of variation. This takes into account the standard deviation relative to the mean of the dataset, as shown in the formula. From the values computed earlier, the coefficient of variation of our dataset is 8.25%. But what if we wanted to find the variance and standard deviation using Microsoft Excel? What are the formulas? Now let's use the same dataset where we used the formulas earlier, and let's find out if we will get the same values if we use the formulas in Microsoft Excel. So if the values are a sample and we wanted to look for the variance, the formula for that would be equals var.s, so s for the sample, and you enclose the dataset in a parenthesis. We get 78. Now for the sample standard deviation, the formula for that would be stdev.s and then the range of the values. And we get 8.83 approximately. Now for the population, the variance would have to be calculated using the formula var.p this time, so p for population and the range of your values. And for population standard deviation, it will have to be stdev.p and your values inside the parentheses. So you notice that these values are the same measures that we have calculated earlier using the manual process. So that's it for variability. Again, these measures give us an idea on how dispersed, how consistent, and how varied the data points are in a distribution. And they are used in conjunction with the measures of central tendency to give us a better picture of what's going on in a data set. Thank you for taking time to watch this video. Please subscribe and get notified for the next videos. I'll see you in the next one.